Hey guys, I want to go ahead and do another just quick video. This just on particle motion and just questions that you might see on the exam this year. All right, so we've been doing some particle motion, and this is from 2018. All right, and it says that a particle moves along the x-axis given by this velocity between 0 and 3.5, and the particle at position x equals 5 the time at time t equals 0. Now be careful, okay, because a lot of times we see x equals 5 and we think, oh, that's the x value. No, remember your x value is your t right here. So this one you would write x of 0 is equal to -5. Okay, just keep that in mind. So now for part A, remember part A should be the easy part. Okay, so let's see if we can do that. It says find the acceleration, boom, of the particle at time t equals 3. What do they give me? Velocity. How do I find acceleration? Acceleration, you have to find the derivative of velocity, okay? That's how I get acceleration. So the acceleration, I have to find v prime of 3. And that's all I do. And this is a calculator question. And so you just take the derivative, plug in the 3, and you should end up with -2.118. Okay? There it is. And how do you answer the question? You would just say the acceleration of the particle at t equals 3 is this. And that's it. Okay? All right, and that would give you 1 point. And yeah, it's easy enough. Part B. It says find the position of the particle. Position. What do they give us? Velocity. So how do I find position? You integrate velocity. Okay, vt dt. From where to where? Well, from what's our initial? From 0, t equals 0 to t equals 3. From 0 to 3. Okay? And what's that going to give me? Well, when you integrate this, your fundamental theorem, you're going to get x of 3 minus x of 0, which is your position. So now what do we want? They want the position at t equals 3. So I'm going to solve for this guy. So essentially, you're going to have x of 3 equals the negative x of O is going to go to the left. You're going to have this guy plus 0 to 3 of vt dt. And that makes sense, right? How do you find out where something is located? Well, where do you start plus how much you travel? Okay. Now, all I have to do now is just use my calculator, plug it in, and I'll be able to do it. So we know the original position, the initial condition, we're at -5, so we can do that. Plus the integral from 0 to 3 of vt dt. Okay, so this would equal to, you put in your calculator, it would be -1.760, and then what's that, 213. All right, so the position of this particle at t equals 3 is this guy. And that's it, guys. And you know what? Part B, believe it or not, is worth 3 points. Yes, it's very important that you set up the integral and that you use the initial condition. And finally, the answer. So that's how they justify. So you can see that sometimes these points, they're easy, but they carry a lot of weight. So if you do part A and B, man, that's already 4 points. You're halfway done. That's at least a 3 on the AP exam. All right, part C. This is a good question. Evaluate the integral from 0 to 3.5 of vt dt and evaluate the absolute value of the integral. Interpret the meaning of each integral in the context of the problem. If you've been with us and you've been seeing these, you notice that this keeps coming up, doesn't it? This always keeps coming up. The absolute value of velocity is, okay, that's going to give you, when you integrate the absolute value of velocity, that's going to give you the total distance. What about when you integrate it without the absolute value? This is going to give you your location or your displacement. Okay, your displacement. And well, if you forgot, what's the difference? Well, let's say you take a trip, turn around, I forgot something. Oh, go back. Oh, no, let's keep going. And you end up at your place here. Well, what's your total distance? Well, you would have to add going forward, going backward, going forward, going backward. Okay, but what's your location? This guy right here, this is your displacement right here. Point A to point B right there, that's your displacement. But your total distance, it has to incorporate everything going forward and backwards. Okay? All right, so let's go ahead and do that. And actually, that's pretty simple because this is a calculator question. So 0 to 3.5 is a vt dt. you plug it in, and you should end up with 2.844. Okay, or 43 if you're truncating. And then the last one, from 0 to 3.5, the absolute value of Vt dt, okay, is equal to now what do you think? Is this going to be bigger or less than? Right? Yeah, you're right. It should be more, right? The total distance, because you're incorporating going forward and going backward. 3.737. So this guy here is the total distance. Okay, and this guy here is displacement. Okay, so understand those two words, okay? Understand those two words. And all you have to do is write the integral from here to here is this, okay? And you would say is the total displacement of the particle from 0 to 3.5. That's it. And this guy you would say is the total distance of the particle from 0 to 3.5. And you're done. And believe it or not, that is 3 points. Not too bad. But I want you guys to see what they're continually asking. Excuse me. But if you notice, same thing, position, total distance traveled. In this case, they ask for displacement. Okay. So relatively, they're going to continue to ask the same type of questions over and over on particle motion. So part D, a second particle moves along the x-axis in the position given by this guy. Okay. Between 0 and 3.5. At what time are the two particles, okay, moving with the same velocity? Okay, so when do they have the same velocity? When are they moving with the same velocity? So think about that. We have this particle here, this velocity, and then we have this position. So basically, when is the velocity of the first particle equal to the velocity of the second particle? Okay. I'll just go ahead and use this notation here. Okay. And how do you find the velocity of the second particle? Well, you have to take the derivative of this guy. Okay. And so hopefully that makes sense. Remember, v of t is representing this guy right here, the first particle. Okay. And then x prime of t, or x sub 2 prime of t, represents the second particle. Okay, so we want to know when the first particle equals the velocity of the first particle equals the velocity of the second particle. Well, the velocity of the second particle, I have to take the derivative, so I end up with 2t minus 1. Okay, that's when they equal the same velocity. You set them equal to each other. Well, now what do? Well, you're going to take your calculator, you're going to solve it, okay, and you end up with t is equal to 1.57054. Okay, so the two particles are moving with the same velocity at this specific time. All right, guys, so hopefully that makes sense, and being able to see what they're asking. So that was from 2018. Let's go ahead and do one more. 2019, see what they tell us. Now this one, they give me a table. As soon as I see a table, I'm already thinking, okay, Riemann sum, something like that. All right, so let's see what they have for us. Okay, you have the velocity of a particle p moving along the x-axis, given the differential equation, okay, differential function, v sub p of t, measured in meters per hour, and t is measured in hours. Okay, select values of v sub p of t as shown in the table above. All right. Particle p is at the origin. Good, that's our initial condition. That's where we start. Remember, part A is the easy part. It says justify why there must be at least one time between this time between 0.3 and 2.8 in which v prime, v sub p prime of t, the acceleration equals 0 meters per hour. Okay. And if you notice carefully, what are we talking about? We're talking between 0.3 and 2.8. All right. Well, look at this. So we're going to be using this. These guys right here with this guy right here. And what is it asking you? Why must the acceleration equal to 0? Remember, this is velocity. And if you notice, how do we find acceleration? We use the derivative. Well, if you notice, look at this is from A to B, 0.3, okay, to 2.8. So you're going to be taking the derivative or the slope, okay? So if you notice, V, and I'll use their notation, V sub P of 2.8 minus V sub P of 0.3, all over 2.8 minus 0.3. Okay, the Y values. What do you notice about the Y values? See? Y2 minus Y1, right? Or F of B minus F of A, 55 minus 55, that's going to give you a 0. And then 2.3 minus 2.8 minus 0.3. Okay, so this is going to give you 55 minus 55 over, what is that, 2.5? 2.5, and that's going to give you 0. Okay, there it is. You showed that the acceleration is 0. But you have to go ahead and justify. Okay, and you would say by the mean value theorem. And I think the teachers would understand if you put MVT, the mean value theorem. Okay, you would say there's one C, there's a C, okay, between 0.3, okay, and 2.8, such that, okay, V sub P prime of C is equal to 0. Okay, and that's what they're asking here. You're using the mean value theorem to show that the slope or the rate of change, the acceleration is 0. Okay, so there's a point during this travel where the acceleration is 0. The particle is not accelerating. All right. Now that was a little bit weirder just because you had to justify, but it's not too bad. Okay. Part B, use a trapezoidal sum with 3 subintervals from 0 to 2.8. Okay. So 1, 2, and 3 to approximate the value of this guy. All right, so we have to use a trapezoidal sum. So the first thing I do is I make my rectangles, 1, 2, 3. Now trapezoid. Now remember the trapezoid rule. You're gonna have to add. Okay, it's 1/2. The trapezoid is 1/2. You add the 2 bases times the perpendicular height. Now these trapezoids are vertically standing up. Okay, so remember, you're gonna this guy here. Okay, I could say this is your base, and then these are gonna be your heights. Your Y values are your heights. Okay, so you're gonna be adding the heights. Okay, those are gonna act as B1 and B2. All right. So how do you set it up? Well, it's 1/2. You're going to write the integral from 0 to 2.8. Okay, V sub P T dt. Okay, and it's approximately, that's what we're doing. So what's the distance between 0 and 0.3? 0.3. And then times what? 0 plus 55 divided by 2. Okay, so 0.3, 0 plus 55 divided by 2. Why divided by 2? That's our trapezoidal rule. All right, do the next one. From 0.3 to 1.7, what's that distance? 1.4. And you add these 2 bases, 55 plus negative 29. Okay, 1.4 and then 55 plus negative 29 divided by 2. Okay, keep going, plus, same thing, from 1.7 to 2.8. What's that distance? What is that, 1.1? Okay, and then negative 29 plus 55. Okay, so 1.1, negative 29 plus 55 over 2. And you should have 3 because those are the intervals that we have, right? 1, 2, 3. 3 rectangles, 1, 2, 3. All right, guys? So if you do that correctly, all right, we should end up with 40.75. Okay, 40.75. All right, that's the value of this guy. All right. Part C. All right. Now you notice they said value, which is kind of interesting because that might come up again. But we'll just leave it like that for now. Part C, it says a second particle Q also moves along the x-axis, and between 0 and 4 given by this equation in meters per hour. Find the time interval during which the velocity is at least 60 meters per hour. Okay, so that means it's greater than or equal to 60. Find the distance traveled by the particle during the interval when the velocity is at least 60 meters per hour. Okay, so let's break it apart. This is the velocity. Find the time when the velocity is 60, at least 60. So we're going to set this guy equal to 60, you guessed it. Okay, so v sub q of t, we're going to set it equal to 60. Okay, and when you do that, and you're going to have to use your calculator for that, okay, graph it or solve it with your calculator, you're going to get two values. You're going to get t is equal to, the first one is t 1.866, okay, and the second one, you're going to get 3.519, okay, of course that's in seconds. And those are your two values, okay? Good, so at that point, at least it's traveling 60 meters per hour, okay? Oh, and I'm sorry, it is hours, okay? So now, we go to the next part. Find the distance traveled by the particle, you see that? Distance. During the interval when the velocity is at least 60. Well, when is it at least 60? Actually, it's going to be between these two values. Okay, it's going to be at least between these two values. Because it hits 60 here, and it also at least hits 60 right here. That's where it crosses 60. It hits 60 here, and it hits 60 here. So, it's going to be between 1.866, okay, and 3.519. It's got to hit those two, okay? So this is your interval of integration. So how do we find the distance? And I wish they would have said total distance. That would have made it a lot easier to understand, okay? But that's okay. So we're going from 1.866 to 3.519. Now remember, it says distance. It says distance, and they mean the total distance. So we want to go ahead and find the absolute value. Okay, the absolute value. The absolute value. And if you do that, you would end up with 106.109. Okay, and that would be in meters. All right, guys. So hopefully that makes sense how we broke it apart, okay? How the velocity, we set it equal to 60, found our critical points. Okay, at those points it's going to be at least 60. And then we just integrated from that to that point. Now it was kind of tricky because as it says, find the distance. I wish they would have said find the total distance, but either way it's okay. Part D, last one. At time t equals 0, the particle is at position x equals -90. Okay, using the result from part B and the function v sub q from part C, approximate the distance between particles P and Q at times t equals 2.8. So the distance between the particles, so we got to find the position of this guy, and we got to find the position of this guy, and then figure out how far apart they are. Does that make sense? So what's the position of this guy? Well, the position is another word for displacement. Did we find the displacement of that guy? Yes, because using the result from part B. This guy is your displacement, where he ends up, his location. Okay? And that, remember, was 40.75. So your position of particle P at 2.8 is 40.75. So this guy gives you the location. Where did he end up? His position, his displacement. Okay, so hopefully that makes sense. Now, how do we find the position of this guy? Okay, well, what do they give me for Q? For Q, they give me the velocity. Okay, they give me the velocity. So what do I have to do? Well, I'm going to have to integrate the velocity of this guy to find the position. From where to where? From 0 to where? 2.8. Okay. Well, if I do that, we're going to end up with the position of the Q particle minus x sub q of 0. So now we need to find the position of this guy. So x sub q of 2.8 equals, I bring this guy across to the left, so it becomes a positive x sub q of 0 plus the integral from 0 to 2.8 of v sub q of t dt. Okay, what's my initial condition right here? Where did the guy start? Oh, check it out. He starts at what? Negative 90. Don't be confused, okay? This is x sub 0 equals negative 90. So that's going to give me, and I'm sorry, didn't give myself enough room here, negative 90 plus the integral from 0 to 2.8 of v sub q of t dt. Now you would just use your calculator to plug in the values, and you should end up with 45.937. Okay, so now we know the position of the q particle, okay, at 2.8, and you notice it is 45.937. So now we can figure out how far they are, the distance between the particles. So all we do is subtract these two, okay, and so the distance is 45.937 minus 40.75, and that's going to equal 5.188 meters apart. Okay, meters apart. And hopefully that makes sense, guys. And we break it down. So that one wasn't too complex, but hopefully these are helping you to see more and more what type of questions are going to ask you. All right, guys, I'll see you guys next time.